what we're going to do is we are going to be finding our horizontal asymptote or our slant asymptote. Horizontal asymptotes you've done before, for sure. You may have done slant asymptotes. I don't know what they do in others. Okay, so we're going to start with the horizontal asymptotes because those will definitely be familiar. So, thank you. I grabbed yours. I'll send it down to resource for you.
Thank you.
So what we're going to do here is we're just going to find our end behavior asymptote. We're going to figure out what kind of asymptote it's going to have. So first thing we do is we look and see the degree of the numerator versus the degree of the denominator. So if we look at this one here, what is the degree of my numerator? 2. What is the degree of my denominator? 2. So what we have there is my degrees are equal, right? So what we do is we take a ratio, meaning a fraction. It's going to be y equals the leading coefficient. So my leading coefficient on my numerator is 3. The leading coefficient of my denominator is 4. Ta-da. So our horizontal asymptote will be at y equals 3/4. So for the horizontal asymptotes, we're just taking the ratio of our leading coefficients. If it's not in P over Q, so if it's in something that looks like this guy, combine our like terms, like we're going to have to make our common denominator and combine it together. And then it's the same thing. So for this right-hand one, I need to make these have a common denominator, which is that means I'm going to take my 4 and multiply it by x plus 2 over x plus 2, right? Vaguely familiar. So that we have 3x minus 4x minus 8 over x plus 2. Vaguely familiar? So when f of x over here is in our P over Q form, ooh, I don't like that. I need a different color. I don't like them smushed together. Too close together. What do we have when we've combined this together? Yeah, negative 1x minus 8 over x plus 2. So what is our degree of our numerator? What degree? 1. What's the degree of our numerator? 1. So we're going to go for our ratio of the leading coefficients. What is the leading coefficient of the numerator? Negative 1. What is the leading coefficient of the denominator? 1. So I'm going to give us some space at the bottom. Our horizontal asymptote, or our end behavior asymptote, is going to be at y equals negative 1. So it's a horizontal line at y equals negative 1. Okay, so when we have even degrees, it's just a ratio of your coefficient. Questions on those two? Because we're going to do at least one example of all of them, of all the different kinds of end behavior we can have. All right. So now we're going to look at if we have a bottom-heavy situation. So what is, on this one here, what is the degree of our numerator? 1. What is the degree of our denominator? 2. So our ratios are off. Like it's not the same. I can't just take the ratio of the coefficients. Unless we come in here and think about this as them having the same term. So how many x squareds does the numerator have? 0. So it has a coefficient of 0. 0x squareds. So if we have a ratio of our coefficients of 0 over 1, what is my asymptote? 0. So if you don't want to have to memorize like 3 different ways of doing it, you can still do it as the ratio of your coefficients. It's just 0 over whatever your coefficient is on the bottom. Because there's no x squareds on the top. I don't have any x squareds. I have none x squareds in the top. So we're doing the ratio of the matching term. And it's always going to be your highest degree term. Or if you are fine with memorization, you can always just say it's y equals 0 if the degree is bigger on the bottom. Okay. And you can do this one the same way that we did the previous one. There's also a shortcut on this one when it's not in our P over Q form. This is our transformation form. We've done rationals before. If you think about our y equals, if you remember our transformation forms like this, plus k. You've seen this before. It's been a hot minute. And we're going to get the same answer either way. So if you want to do it just like we did on the last one, we can do that. Get to our common denominator. 3 over x plus 2. And we're multiplying our 4 by x plus 2 over x plus 2, right? Minus 4x, again, minus 8. So we wind up with our f of x minus 4x minus 5. So if we wind up with a constant added on to our rational function, where's our asymptote going to wind up when we do our ratio here? It's going to wind up being the k value. So just like when we did our ratio over here when they were the same, we took our ratio of our leading coefficients. Take our ratio of our leading coefficients. -4 over 1. Or just -4, which is our constant here. It is our vertical shift. Yes, dear? The 3 minus 8. So I just combined it together. It doesn't have any impact on our asymptotes, but it's still there. It's hanging on. So if you want to get it to your common denominators every time, that's totally fine. But if we have no x's in the numerator and a constant, shortcut is that's your K transformation. It is your vertical or it is your horizontal asymptote. Okay, we've seen that before. This gives us our end behavior. This tells us where we're headed. We have one more option for end behavior, and then on Monday we're going to graph a gazillion of these and combine them all together. Okay? So our last option is when we have more x's on the top than we have on the bottom. I've got an x squared on the top and an x on the bottom. So the way we find our asymptote is we're going to need to do this division, because our asymptote is going to be the equation of y equals whatever our quotient is, whatever the top guy is when we divide. So we're going to divide x squared plus x plus 3 by x plus 2. You can use long division. You can use synthetic division. I tend to use synthetic because I like the lazy way. If you love long division, go for it. You should get the same answer. So I'm going to write my coefficients for my numerator. 1, 1, and 3. -2. Good catch. That was my next question. So we drop the 1. -2. What do we get underneath that? -1. +2. What's our remainder? 5. We don't actually need the remainder, but I don't like leaving things half done. What is this expressed back as an expression? X minus 1. This is our asymptote. Whatever the pieces we got when we divided, that's our asymptote. So when we graph them, it's going to give us a diagonal line, and that's the asymptote. So it's going to be a slant asymptote. Okay? So when we're looking at these, and when we're going to graph these, we're going to need to check all the things we went through Wednesday and today. We're going to check for holes. We're going to find x-intercepts, y-intercepts. We're going to find horizontal asymptotes, vertical asymptotes, end behavior asymptotes. We're going to find all of the pieces and plot them up. And that's what we're going to do on Monday. And Tuesday. Like the e-learning stuff is going to be going through this stuff and working on the review. Okay, so they're long, but they make really pretty graphs. They're swoopsies.
That's what we're working towards.
Okay, so that's what we're going to do on Monday. We'll graph the heck out of these, and Tuesday we'll graph more of these and start working on the review. Wednesday we'll have none graphing, Thursday's review. And we're going to move the test to Friday, not Thursday. Test will be Friday next week. The test is Friday.
Actually, I'm not going to be here Thursday.
So test is going to be Friday. That puts us testing the same day as the other class. Okay? Hang on. Let me end.